Today we will discuss about the topic critical section in operating system. What is critical section problem? Consider the system of n process P0, P1, P2 up to Pn minus 1. Each process has a segment of code. That segment of code we can call it as critical section. In critical section, the process may be changing common variables, updating the tables, writing files, and so on. When one process is in critical section, no other process is to be allowed to execute in its critical section. This is the most important line. When one process is in critical section, no other process is allowed to execute in its critical section. That is, no two processes are executing in the critical section at the same time. Each process must request a permission to enter in its critical section. The section of code implementing this request is the entry section. The critical section may be followed by an exit section, and the remaining code is the remainder section. Look at this representation. Do open braces, and they mentioned the entry section, and then will it go for a critical section. Once the critical section was complete its process, complete its changes, it will move to the exit section. After exit section, it will go for a remainder section and then comes out. So this is the basic structure. Once the process needs a permission, through the entry section, and then it moves to the critical section. A segment of code is moved to the critical section. Once it was updated or edited, then it moves to the exit section, and then it ultimately moves to the remainder section, and so on. What is the solution for a critical section? We know what is a critical section. If one process is in critical section, no other process will enter in its critical section. So we have certain solution. One is a mutual exclusion, other one is a progress, other one is a bounded waiting. What is mutual exclusion? If P1, the process Pi is executing in its critical section, then no other process can execute in their critical section. So only one process is going to execute in its critical section. Simply, it mutually excludes the other process to enter in its critical section. That's called the mutual exclusion. Coming to the progress, if no process is executing in its critical section and there exists some process that wish to enter their critical section, then the selection of the process that will be entered in the critical section next cannot be postponed indefinitely. Bounded waiting. A bound must exist on the number of times that the other process are allowed to enter in its critical section. After the process request to enter in its critical section, and before that the request is granted. This is called bounded waiting.